All right, good morning or good afternoon, whatever time you're watching this. So we're going to go over the law of cosines. So I'm going to record this without a class so that a day you have something to look at here. So we're just going to cover law of cosines today. So last time we talked about law of sines, which was for non-right triangles in the case of angle side, angle side angle, or the angle side, which was the ambiguous case that we kind of skipped over. So you have two cases there. Now we are going to do the law of cosines, and I will tell you what those are applicable to in just a minute. You'll see what the difference is between the two for law of sines or law of cosines. But first, I wanted to derive this for you quickly. You will not have to know this for the test, but it's good for you to know where this comes from. So again, this is for non-right triangles. So we are going to take a triangle over here, which is non-right, the ABC, the bigger triangle. And we're doing the same trick like we did with the law of sines. We are going to do the trick of taking the altitude and splitting it into two right triangles, one on the left, one on the right. So again, remember the sides are named. Whatever the angle is, the side opposite is, like for angle A, side opposite is A. For side angle B, side opposite, the whole side there is B. And angle C, the side opposite is C. We have now two other, the right triangles now. So I'm naming this part over here from A to D. I'm just calling that R. So if the whole side opposite of B is side B, this little piece over here is B minus the R here. So I just arbitrarily called from A to D, I call that R. And then over here on the right-hand side triangle, I call that is the whole side B minus the R right here. All right, so we're going to derive this real quickly. So if I take the sine of angle A, here's angle A. Remember, you're doing right triangles for SOHCAHTOA. So this is applicable now. So angle A opposite over hypotenuse would be H over C, right there, H over C. Opposite over hypotenuse. Cosine, the cosine of angle A. Now, cosine of angle A is adjacent over hypotenuse, so R over C. All right, so what we did here, solve for H, just multiply by C on both sides, so you get H is equal to C sine A here. Solve for R, get R by itself, multiply by C on both sides, so R is equal to C cosine A. Now we're going to look at this other right triangle on the right-hand side over here. And we're going to apply the Pythagorean theorem to this right triangle over here on the right side. So it's going to be leg squared times leg squared equals hypotenuse squared, or h squared times plus b minus r squared equals a squared. All right, so that's where we got that right there. Leg squared plus leg squared equals hypotenuse squared. Well, guess what? What is h? You just solved for h up here, right? So we're going to substitute for h. We're going to substitute in c sine A. And b minus r, we just solved for, so we're going to substitute in for the r, the c cosine A. So here we go, leg squared plus leg squared equals hypotenuse squared. We just substituted in for the h and the r there. All right, so now this is just a giant FOIL. B minus c cosine A squared, that whole thing squared, is b minus c cosine A times b minus c cosine A. And if you FOIL that out, you get this right here. Okay? And then that just carries down there. All right, so if we're okay with that, this squared, right, c sine A, all of that squared is c squared sine squared A, okay? Same thing. These two are the same thing. All right, so now what do? we took this with the underline, and we took that with the underline, and I just grouped them together over here. I just put them over here and then move these over here. We just rearranged things for a minute. Okay, now that we have these together, look, they both have a c squared in them. Factor out the c squared. If you take a c squared out of this term, you're left with a sine squared. If you take a c squared out of this term, you're left with a cosine squared a. All of this just remains the same. Carry it from the previous equation. Well, guess what? Sine squared of an angle plus cosine squared of an angle equals a 1, the basic identity. So what is c squared times 1? Just c squared. And all the rest of this just carries down. And guess what? You have just derived one of the laws of cosine right there. Right there. It is not impossible to do. I mean, you know how to do all of those things that I just showed you. So there it is. It's in your notes. You can look at it again at leisure. You can also pause and go back and read forward. But here are, I'm not going to derive every single one, but they're all the same idea. There are 3 laws of cosine. Okay. If you will notice, it's a squared equals b squared plus c squared minus 2bc cosine a. That's angle A there. That the a squared, which is a side, all the little letters are sides, all the capital letters are angles, okay? So you notice that the a, side A, and the angle A, those are on 2 opposite ends of this equation here. The next equation was with side B, b squared equals a squared plus c squared minus 2ac cosine B. And the last one, c squared equals a squared plus b squared minus 2ab cosine C. C and C on opposite sides, B and B on opposite sides, A and A on opposite sides. So if you're looking for side A, you use the other 2 sides that you're given. That's the B and the C, again, the B and the C, and the angle in between. Okay. If you're looking for the side B, you're using the other 2 sides, and the cosine of B. Okay. Same with the C. All right, so these are to find the sides, and we'll talk about finding angles later. All right, so I'm going to work a couple of problems right now. So let's do some example problems. Here's the first one, law of cosines for the case of, guess what? Side, angle, side. Okay, so I'm going to draw a very exciting triangle here, a non-right triangle, and we're going to call this A, B, C, and we're going to say that C is 60 degrees, and we're going to say that A, remember A is opposite here, side A is equal to 2. And here is, over here, opposite here is side C. And then over here, opposite angle B is side B, which is equal to 3. So here you go again. You have a side followed by an angle followed by a side. Side, angle, side. That's what you were given. You don't know angle B, you don't know angle A, you don't know side C. You have a side, 2 sides with the angle in between. All right. So let's find the missing side C. Okay, so which one of those do you use? The one that has the c squared on it. All right, so whatever side you're looking for, you're using the other 2 in the equation, a squared plus b squared minus 2ab. And then the cosine of the same angle. That's always what's at the end there, okay? Like that. So you literally, we can just plug these things in here. C squared is equal to, what is A? 2 squared, side A. And what is B? 3 squared minus 2 times what's A again? 2. What's B again? 3. Just substitute everything in there, and then the cosine, and what's C? 60 degrees. So you literally plug that whole thing in there, and you're going to get C squared is equal to 7. So people, my biggest advice is to do this all in one shot in your calculator. Okay, so we might have to practice that in class, make sure that you're okay with that. But this is the part that with the law of cosines, people have the biggest issue with their calculators, because you're trying to do many steps everywhere, and then the calculator, you just get lost in there. Try to do this whole thing right here. Try to do that whole thing in one shot if you can, okay? So you get C squared equals 7. Here is the next big thing that people forget to do. They think they're done because you're like, oh, that big long thing, I'm finally done. No, you want C. You don't want C squared. So you got to take the square root of both sides. So C is equal to root 7. Okay. So again, most of the time when you're taking a square root, you have plus or minus, but if it's a distance, you don't have a negative distance. Okay, so C is equal to the positive there. All right, so now what are we going to do? We're going to find angles A and B. So first we're going to find angle A. Find A. So the way we're going to do that, we're going to use the law of cosines in this case right here, okay? Yes, just to avoid that we're using the ambiguous case, we're just going to use the law of cosines. It's a little bit trickier right now, okay? So to find angle A, you want to use the formula that has angle A in it. In that case, it's going to be this one, right? B squared plus C squared minus 2BC, right? The other two angles, and then the cosine of angle A. So if we're using law of cosines and we're trying to find angle A, we have to use the formula that has angle A in it out of those three that I showed you from before. Okay, so here's what I would like you to do to also keep from getting too confused. Let's try to get to angle A before we plug all of these numbers in. This is just my biggest piece of advice. Okay, so first thing we're going to do, let's subtract B squared, and let's subtract C squared from both sides. Just the way it is, just the formula, the way it is, okay? So you're going to get on this side A squared minus B squared minus C squared is equal to, right, and these have canceled out, negative 2BC cosine of A. Now we're getting down, we're trying to get to angle A, remember? So trying to get peel some more layers away. So let's divide by negative 2BC on both sides. Okay, so this is all gone, and this is all gone. Okay, so now you're going to be left with this, A squared, excuse me, let me clean that up. Okay, so that's gone. A squared minus B squared minus C squared, all divided by negative 2BC, is equal to the cosine of A. Well, if you remember this, how do you get to the A there? And so you don't want cosine of A, you want A. What do you do to both sides? You do the cosine inverse of both sides. That's how you get rid of the cosine. Okay, so that whole thing gets rid of the cosine there. So you're left with an angle A is equal to the cosine inverse. I would literally do all this algebra first. And then now we can plug in some numbers. Okay. So let's plug in some numbers. So I'm going to do it over here so you can see it. Cosine inverse of what is the A? Okay, let's look up there again. A is equal to 2, side A. So it's going to be 2 squared minus B squared. What's B is 3. 3 squared minus C squared, which is, what is C? Root 7 squared. All of that divided by negative 2, and what was B? 3. What was C? Root 7. Okay? And then close the parentheses. So here's the trick. Here is the trick. So you did all that algebra so you could just cleanly plug everything in there, the A, the B, the C, and the B and the C down there, okay? Now, when you're doing this in your calculator, make sure, again, you're in degree mode, okay? And also what I would do is I would add in here, and I'm going to put these in here, a parentheses around this part and a parentheses around this part, okay? So we can work on the calculator stuff in class if you're having troubles with it, but that's the biggest thing. Like if you trying to peck away at this, you are almost going to have issues if you're doing a piece at a time. It is way better to do the whole fraction here like this. All right, I have to find the function for you, but I know there's a function where it allows you to have a numerator and denominator on the TI as well, okay? I forget what that is offhand. But you plug all of that into the calculator and you should get, for your angle A, after all of that's in there, you should get 40.9 degrees. Okay? So if you have your angle C and you now found your angle A, your angle B is just 180 minus those two. But we're just going to use the law of sines just for fun to find out your angle B right here. So let's find angle B using law of sines. Okay. So let's see. Let us use this one here. See, you've got the angle and the side here. And then you're trying to find angle B anyway. So we'll use those two for the law of sines, okay? So it's going to be sine of C over C over equals sine B over B, like that. So it's sine of 60 divided by the side C, which is root 7, is equal to the sine of B, which you don't know yet. See, this is a little bit different because you're looking for the angle, not the side, over 3. Do a cross multiply. Okay, so root 7 times sine of B is equal to 3 times the sine of 60. Trying to find B, so let's peel away, divide by root 7, both sides. Okay, so those are gone now. So you get the sine of B equals 3 times the sine of 60, all divided by root 7. And guess what you do? To get to angle B, you're going to have to undo that sign in front of it. You have to take the sine inverse of both sides. So your angle B is going to be sine inverse of 3 sine 60, all divided by root 7. There you go. And so B, if you put that in your calculator, sine inverse of 3 sine 60 divided by root 7 should give you, when you do that in your calculator, should give you 79.1 degrees. Okay, of course, you didn't have to go through all of that. You could have just subtracted from 180. I was just showing you for practice purpose, okay? All right, so here's the A. So 40.9 plus 79.1 plus the 60 degrees, they should all add up to 180. Okay, there you have it. So you can pause this here if you need to. Okay. There you go. All right. So now I'm going to do one more problem with you and then we'll stop, okay? Don't want to give you too much. All right, last problem. So now we're going to do the law of law of cosines, and we're going to use side, side, side. Okay. So again, very exciting triangle here. And it's going to be ABC again. So again, opposite A, angle A is side A, which is going to equal 4. Opposite B is going to be side B, which equals 3. And opposite angle C is side C, which equals 6 in this case. So what do you have? A side and a side and a side. You have 3 sides, nothing else. So now we're going to be looking for all kind of angles that are missing in there, right? We're going to want to find angle A, angle B, and angle C. So I think we're going to call it a day. Once we found 2 angles, we're going to be good to go. Okay. So if you can imagine from the last problem, if we're finding angles, and based on sides, we're probably going to have to do inverse sine or cosine or something on there. Okay. All right. So let's go ahead and find angle A. Find A. Okay, so guess what? If we're finding A, angle A, we're going to use the one that has the angle A in the formula. So the other 2 sides minus the 2 of them times the cosine of angle A. So my advice again is to do the algebra first. So let's subtract these 2 from both sides. Okay, same. Okay, so you're going to end up with a squared minus b squared minus c squared is equal to negative 2bc cosine A. And then just do a little division there, minus 2bc on both sides. Okay, so you're going to get the cosine of A is equal to a squared minus b squared minus c squared all over negative 2bc. And guess what? Again, to get to the angle there, you're going to have to do cosine inverse of all of that thing there. So make sure this is all together as 1 before you divide it by negative 2bc. Okay. All right, so now we can just plug all that in there. We can plug the values in. So it's going to be cosine inverse of what is a squared? A is equal to, I'll make it smaller so you can, sorry, too much. A is equal to 4, right? So it's going to be 4 squared minus what's B? B is equal to 3, so 3 squared minus, and what is C equal to? 6, 6 squared. Okay, all of that divided by negative 2 times, and B is again 3, and C is again 6. Look at the numerator, y'all. 4 squared minus 3 squared minus 6 squared, that's going to be a negative number. So that negative number on the numerator is canceling out with that negative on the denominator, in case that was bothering you, that negative downstairs. the numerator almost always is negative. So that negative downstairs in the denominator cancels that out. So just do it the way it is. Just plug it all in there. And when you have done that in your calculator, you should be getting an answer like 36.3 degrees. Okay, make sure you're in degree mode. Okay. Next thing, let's find angle B. So we'll use law of cosines then again, just for the giggles. Okay, so I don't think you may not have enough information there for law of sines to use that anyway. And I'm going to tell you when to use what here in a second. It's a pretty straightforward rule. So let's now do find angle B. And we'll use law of cosines. So again, if you're finding angle B, you got to use the one that has the angle B in it. So that's B squared there. Then the other two sides, excuse me. The other two sides, A and C, minus 2AC, cosine of angle B. Again, do this algebra first. Just do all that, minus A squared minus C squared. Okay. So you're going to end up with B squared minus A squared minus C squared equals minus 2AC cosine B. Get rid of the negative 2AC. Okay, so yeah, I missed an S there for cosine. Okay, so it's going to be B squared minus A squared minus C squared all over negative 2AC is equal to cosine of B. And then again, you're trying to go for the angle, so you got to undo that cosine there in front of it. So do a cosine inverse on both sides. Okay, so you have a cosine inverse of, now here it comes, numerator. What is B again over here? Look at that, B is equal to 3. So it's going to be 3 squared. What's A? A is equal to 4. So it's minus 4 squared. And what is C equal to? C is equal to 6 minus 6 squared. All of that over negative 2 times, and what was A again? 4 times C. What was C again? 6. You're literally plugging all of that in there, okay? Again, if you look at 3 squared minus 4 squared minus 6 squared, that's like 9 minus 16. That's already negative, right? Minus 36. So that whole number upstairs in the numerator is negative. So that negative there will cancel out with that negative right there, okay? If you plug that all into your calculator very nicely, again, the whole of the numerator divided by the whole of the denominator there, you should get a number like this, 26.4 degrees. Check it out, make sure you can do it. If we're having issues with that, we definitely need to get that solved before the test. And now for angle C, I would just do 180 minus those two. Right? 180 degrees minus those should be equal like to 117.5 degrees. And there it is, finished with that. So just a real quickie. Here's this. If you want to look at this, pause the video, copy it down. And just a real quick short moment here before I move on, pause if you need to. This is a real fast here. When do I use law of sines? Law of sines versus law of cosines. When? Guess what? This was angle, side, angle, and angle, angle, side, and this, right? Law of cosines, we did side, angle, side, and side, side, side. What do you notice going on here? Law of cosines, even when you look at the formulas, this is all about more sides. Okay, so these are the cases right here when you use law of cosines. What do you find going on here? More angles, except for the, guess what? Okay, so look, here you have more angles, here you have more sides. At least two sides there, at least two angles there, except for, here's another reason to remember that one.